Hello, everyone. Today we will learn about the disassembly methods for single-cylinder diesel engines. Having already gained a basic understanding of the structure of a single-cylinder diesel engine, can you now proceed to disassemble it based on this structure? This course builds upon your knowledge of the single-cylinder diesel engine structure and focuses on its disassembly and reassembly to deepen your understanding of diesel engine components. Pre-disassembly guidelines. First, thoroughly review the disassembly instructions and familiarize yourself with the fundamental technical data. Next, examine the overall layout of each system and take note of any special features to avoid errors during reassembly. Before beginning the operation, ensure that you have implemented proper protective measures and completed all necessary preparations. Avoid working while the engine is running or at high temperatures. Always prioritize safety. Next, let's examine the external structure of single-cylinder diesel engines. As shown in the diagram, the external structure primarily consists of the water tank, fuel tank, lifting ring, silencer, air filter, nameplate, transport bracket, side cover, hand hole, reduction motor, and starter motor. The schematic diagram of the single-cylinder diesel engine structure is shown as follows. The cylinder block contains a cylindrical cylinder, within which a cylindrical piston is located. The piston can move up and down along the axis of the cylinder. The crankcase is fixed to the lower end face of the cylinder block. The crankshaft is located within the crankcase and is supported on both sides by the main bearings at its ends. The cylinder is connected to the crankcase, with the connecting rod linking the piston inside the cylinder to the crankshaft inside the crankcase. The upper end of the connecting rod is hinged to the piston via a piston pin, while the lower end is fitted onto the crankshaft's connecting rod journal. The cylinder head is secured to the upper end face of the cylinder block, enclosing the cylinder. The fuel injector is mounted on the cylinder head, with the nozzle positioned within the combustion chamber. The intake and exhaust valves are used to open and close the intake and exhaust passages. These valves are driven by the camshaft through the rocker arms. Next, here are the detailed steps for disassembling a single-cylinder diesel engine. Step 1. Drain the three fluids. 1. Close the fuel tank valve. 2. Disconnect the high-pressure oil pipe from the pump end fitting. 3. Open the fuel tank valve to drain the diesel. 4. Remove the engine oil drain plug to drain the engine oil. 5. Remove the water valve to drain the coolant. Step 2. Disassemble the intake and exhaust assemblies. 1. Remove the air filter and intake pipe assembly. 2. Remove the exhaust pipe and silencer assembly. Note: keep the cylinder head cover in place for dust protection. Step 3. Remove the side cover. Note: remove the bolts in a diagonal sequence. Step 4. Remove the cylinder head. Note: remove the bolts in a diagonal sequence. The cylinder head is secured to the cylinder block with cylinder head bolts and serves to enclose the cylinder. The recessed area on the underside of the cylinder head, in conjunction with the piston top, forms the combustion chamber. Due to the high thermal load and complex shape of the cylinder head, it is prone to thermal deformation and cracking, thus it must be cooled. The cylinder head has a hollow structure, forming a water jacket that surrounds the combustion chamber. The water jacket is connected to the cylinder block's water jacket through small holes, allowing coolant from the cylinder block to enter the cylinder head for cooling. The cylinder head water jacket has an outlet connected to the outlet pipe. The cylinder head also contains intake and exhaust passages, with valve seats installed in the passages. Valve guides are also installed in the cylinder head for the intake and exhaust valves. The rocker arm assembly of the valve mechanism is mounted on the upper surface of the cylinder head and enclosed by a valve cover. Injector mounting holes are provided in the cylinder head, and the injectors are secured with bolts. Step 5. Remove the flywheel. The flywheel is a large rotating disc that stores a portion of the work transmitted to the crankshaft during the power stroke. Its primary function is to overcome resistance during other strokes, drive the crank and connecting rod mechanism past the top and bottom dead centers, ensure uniform and smooth rotation of the crankshaft, and help the engine handle short-term overloads. Step 6. Remove the piston and connecting rod assembly. First, examine the structure of the connecting rod's big end bearings and main bearings, noting any markings and identification. Review the design and installation features of the crankshaft, as well as the characteristics of crankshaft bearing lubrication. Then, symmetrically loosen the connecting rod big end bolts on both sides until they can be manually turned. Support the lower bearing cap and loosen the nuts. Remove the lower bearing cap from the connecting rod, carefully pull up the piston and connecting rod, and once the connecting rod is clear of the crank pin, lift it out. Then, disassemble the piston pin, and connecting rod. The piston has two primary functions. First, the top of the piston, along with the cylinder head and cylinder wall, forms the combustion chamber. Second, it bears the gas pressure and transmits this force through the piston pin to the connecting rod, which drives the crankshaft to rotate. The piston undergoes high-speed reciprocating motion within the cylinder, experiencing periodic variations in gas pressure and inertial forces. Additionally, its top is in direct contact with high-temperature gases, and with issues such as inadequate lubrication and difficult heat dissipation, the working conditions for the piston are extremely harsh. Therefore, the piston must have sufficient rigidity and strength, be as lightweight as possible, possess good thermal conductivity, and exhibit excellent wear resistance and thermal stability. Step 7. Remove the main bearings and the lower bearing shell. Step 8. Remove the piston rings. Piston rings and the cylinder liner constitute a critical moving pair in diesel engines. They are subjected to the effects of high temperatures and high-pressure heat, including extrusion and scouring. These conditions generate significant mechanical and thermal stresses on the metal surfaces, and severe friction occurs at the working surfaces. Statistics show that friction between the piston rings and the cylinder liner accounts for about half of the power loss in a diesel engine. Piston rings are classified into two types based on their function: compression rings and oil rings. Compression rings primarily seal the cylinder and dissipate heat, while oil control rings mainly regulate oil lubrication and scrape excess oil from the cylinder wall. Compression rings achieve sealing and heat dissipation by applying their elastic tension and the gas pressure in the cylinder to maintain close contact with the cylinder wall and the ring groove surface. Use piston ring removal pliers to disassemble the piston rings. In this lesson, we have covered the disassembly steps and precautions for a single-cylinder diesel engine. You may practice these steps independently to reinforce your memory. Remember to always adhere to the disassembly precautions, and ensure proper protective measures and preparation to avoid injury. Finally, please consider the differences between a single-cylinder diesel engine and a four-cylinder diesel engine. This concludes today's lesson. Thank you for watching.